Okay, for the first chapter 2 is basically all the linear kind of thing. So first exercise is solving linear equations. I'm not going to solve that with you now on the lesson, but I would say enjoy example B, like you take you really long time, but inside there are a lot of good practice, like it's very long question, but there are actually a lot of things which is really worth us to do. So like how to factorize, how to cancel that, how to grouping that. So it's a really good question. So I want you to spend some time on this one, maybe 5 minutes to sit down to do this one. I'll give you answers later. I have the answer for this one. For example B, solve the pair of simultaneous equations by substitution and elimination. So we know what substitution. Substitution is you put one equation into another one. So to do substitution, we will make x to be the subject or to make y to be the subject. So to do elimination, we will add or subtract between two equations. Okay, so that's what substitution was elimination. I think some students still confused about like those two methods. So make it easy. Substitution is make x or y to be the subject, put x into another function or put y into another function. And elimination is add or subtract between two equations. Okay, example 3. Example 3. Example 3 is like a question. You will set up x and y coordinates, x, y values, and you try to set up simultaneous linear equations. Nothing hard, still like year 10 level math, so I'm not going through that. Okay, so here is important. Linear literal equations and simultaneous linear literal equations. So we solving some equations involve x as variable, but also involve other letters a, b, c. So if other letters a, b, c is there, they're not variables, you treat that as a number. So how we can solve this type of questions? Some students have difficulties about like see letter as a number, like they see, oh, that's a letter, all the letters needs to be on one side. I'm trying to solve for every single letter. That's not the case. So how we can solve for this one? First, when you see this question, a over x equals to b over 2x plus c, you see denominators and you know like I don't like denominator. I will get rid of denominator first. So how we can get rid of denominator? We have x and we have 2x. So the first step we will do is times 2x on both sides. Okay, times 2x on both sides. So for this side we will have 2a. For this side we will have b plus 2cx. Okay, what we'll do is, when it's a linear equation, and we will put the terms involve x on one side, the terms not involve x on the other side. So what we will have is 2a minus b equals to 2cx. Then next step will be divide the coefficient in front of x. So what's the coefficient? The coefficient will be 2c. So x will equals to 2a minus b over 2c. Okay, so nothing different, is just change all the numbers to letters, and we should be able to see those letters as numbers. Okay. So that's this example, and let's have a look at next example. Next example is solving for polynomial x and y. Okay, solving for x and y. What I will do is I will name equation number 1 and name equation number 2. This question is very unlikely to use elimination. So I will rearrange part 1 to make y equals to 2x minus 5. And I'll name this as equation number 3. I'll sub 3 into number 2. So x times y is 2x minus 5 over 12 equals to 1. X times 2x minus 5 will be 12. That's a quadratic. Okay, that's a quadratic. So it's 2x squared minus 5x minus 12 give you 0. Okay, how to make a 5 by using 2 and negative 12. So let's say 1 and 2 here. 3 and 4. 3 and 4 is not working. It's 8 and 5 is not working. So 2 and 6. 6. Not working for this one. Okay, what's discriminant? B squared is 25 plus 4 times 2 times 12. That's 25 plus 8. 96. 122. So it's 11 squared. So this one will be a whole number as solution. Okay, I should be able to what's the 3? What x plus? Okay. Yeah, 8 and 3. Yeah. Okay. Yes. Thank you. So 8. I need minus 4. So it's minus 8 and plus 3. So it's minus 5. So we have x minus 4 and 2x plus 3. That is 0. So I'll have x equals to 4 and x equals to negative 3 over 2. Negative 3 over 2. It's not finished. Not always remember we still have y to solve. So you will say when x equals to 4, y will be, what is y? Y is 2x minus 5. So it's 2 times 4 minus 5. Y will be 3. And then when x equals to negative 3 on 2, y will equals to 2 times negative 3 on 2 minus 5. Y equals to minus 8. Test for 12. Yep. Okay, so we have those two pair of values. Okay, next one. Next one is linear coordinate geometry. So I have talked about this since year 9. So I teach year 9 until year 12. I talk about this every year. So if give you 2 points, x1, y1, x2, y2, you can find 3 things by using 2 points. The first thing is the gradient of the linear connecting those 2 points. The second is the distance between those 2 points. Third is the midpoint between those 2 points. Okay, you should be able to know those 3 formulas by now, okay, because we learned that since year 9. And the only thing I want to talk about is what's the gradient really represent? The gradient really represents the tangent theta. So what is tangent theta? I think you learned that in year 11. But like to make you still remember, I'll say I have a linear sketch on the line. The positive part of the linear and the positive side of the x-axis will form the angle. So this angle will be theta here. Let's say we have this line y equals to m1x plus c. So this tangent theta will equals to m. So this tangent theta will give you the gradient. Okay, tangent theta, the theta is the positive side of the line and the positive side of the x-axis will form an angle. So which means if it's a decreasing angle, if it's a decreasing linear, okay, so the linear looks like this. So the positive part of the line, like the up, okay, the up part of the line and the positive side of the x will form an angle, which will be, I'm taking the wrong thing, which will be this one. Okay, that is the angle theta. So let's say y equals to m2x plus theta, x plus c. So tangent theta will equals to m2 for this one. Okay, so which angle you take? The angle will be positive side and form an angle. That gives you the theta. Okay, so let's have a look at one question. And also the information is give you two pieces of information how we can find linear equations. I hope you know that now. So to teach this, I always think about two things. Okay, the first thing we think about, do we know gradient or not? Okay, do we know the gradient of the line already? Do we have information about the gradient of this linear? Okay, if it's yes, we'll go to think about, do we know the y-intercept? If that is a yes, we will use y equals to mx plus c form. Okay, if that is a no, we will use y minus y1 equals to m x minus x1. Okay, we'll use this formula to find that. Think about y. If we know the gradient and intercept, which means we know m, we know c, put the value directly in. If we don't know the y-intercept, which means I don't have c information, which I can use another equation, y1, y2, x1, x1 and y1 to put into the equation, and then make y to be the subject. Okay, the next step is make y to be the subject. Okay, make y to be the subject, and we finished. Let's go to this side. And if we don't have the gradient, okay, then which means find gradient. How to find gradient? Gradient equals to y2 minus y1 over x2 minus x1. Go to find the gradient. And after you find the gradient, we'll go to check. Okay, do we have y-intercept? Okay, that's the flow chart. Okay, to find linear equations is pretty easy. Okay, do we know the gradient? If we know that, move on to the next step. If we don't know that, go to find the gradient. If you already know the gradient, do we know the y-intercept? If we know y-intercept, that will be the really easy case. Pull out the m and c values. If we don't know the y-intercept, we use y minus y1 equals to m x minus x1. And then the last step will be make y to be the subject. Okay? Okay, so what we know from linear, we know 2 points and we can know 3 pieces of information. We know gradient, we know the length, and we know the midpoint. And by the gradient part, we also know that's the tangent theta. By knowing the gradient, we can know the angle formed by the linear and the x-axis. Okay, we will have questions similar to that. We will see questions later. Okay, so that part is talking about how we can find equations of a linear. And the next thing is talking about parallel and perpendicular. If it's parallel lines, the two gradients must be equal. If two gradients are equal, those two lines must be perpendicular, parallel. If two lines are perpendicular, we must have gradient times together to give you -1. So if one gradient equals to the negative reciprocal of the other gradient, they must be perpendicular linears. Okay, they must be perpendicular linears. So that's parallel and perpendicular lines. That's what I just like put all the information here for you. Okay, that's everything you need to know for your linear. Let's have a look at examples. I'm not going to do these examples here because it's a pretty good example for part C. So let's do this as homework. Okay, let's do this as homework, and tomorrow I will go back to this question and teach this. Okay, I'll go back to this question and teach this. So try this first. Okay, it's kind of like short answer and analysis questions. So try this first and I'll go through that tomorrow. I want you to write one question down here. I forget to put the questions here. Put one question down here. Y equals to 2x plus 1 and y equals to minus a third x plus 1. what is the acute angle formed by these linears? Okay, so we have y1 equals to 2x plus 1, we have y2 equals to minus a third x plus 1. I want to know what is the acute angle formed by these linears. Okay, two lines will form an angle, right? One is the acute and one is obtuse. If they perpendicular to each other, both angles 90 degrees. Okay, so if we can do this, let's think about, if you don't know how to do this type of question, a graph will always help. Okay, a graph will always help. So how we will do this? I will draw the linear up here. Okay, we have line here. We have 3, 0, and 0 and 1. And other one will be 0, 1 and negative a half. So okay, then we have this one. Let's say we have theta 1 here, and we have theta 2 here. Okay, why I label theta 1 and theta 2? Because I know the gradient of that, so I should be able to work out what are those values. And tangent theta 1 will equals to negative a third, right? Tangent theta 2 will equals to 2. So what is theta 1? What is theta 1? Let's put this into your calculator. For those type of questions, they may ask you to keep your answers in the degree form. Okay, in the degree form. I'm not going to change this to degree form. So I'll still keep this in radius form. You can see I still RAD, still in radius form. But what I will do is, I will do tangent inverse. What's the value? The value is negative a third. Okay. I'll press enter. Control and enter give me the approximation value. Okay, so this is in the radian form. I want to convert that into degree. So how I can convert that into degree? I will times this value by 180 over pi, right? Times this by 180 over pi. Okay. Radius degree convert to degree times 180 over pi. So that gives you this much. Okay, negative 18. Why is a negative number? Why is a negative number? Because when you do tangent inverse, if you learn Spanish, you know that they will only give you particular part of angles. It's from negative side to here. So each side for 90 degrees and 90 degrees. So it will only give you negative 90 to positive 90 this much. So it won't give you an obtuse angle when you do tangent inverse. So where does negative 18.43 represent? This negative 18.43 is actually represent this angle. This is negative 18.4349 blah 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 blah. It represent this angle. Okay? If that represent this angle, if I add 180 degrees, that will give me the theta 1, right? So let's do plus 180. That gives me 161.565. So 161.565 degrees. And let's do theta 2. Let's do theta 2. So theta 2 will be tangent inverse of 2. Okay. So tangent inverse of 2. That gives me this. I will time this by I want to show you this, but like how I can show you this. If you want to, okay, I will show you here. Just wait me a moment. I want to show you a function which I'm not sure if this will. Okay, you want to copy. Okay, you want to copy this. For example, not necessary for this question, but say in the exam you really want to only copy part of your text from the previous line. So how you can do that? So your text calculator is actually the same as a laptop, as a computer. So in the Word document, if you want to highlight things, you hold Shift button and then press the right or left thing to highlight things, right? So it will same to this part. So say you put the arrow here, see next to 180 over pi. So you hold the Shift button. You hold the Shift button and you press right. It's not going to work on my on my laptop. So if you have your test now, hold the Shift button and press the right. Okay, press right, and it will highlight the 180 over pi for you. Okay, and then you can press Control C. Okay, Control C is same as copy. Okay, same as copy, and you paste that. So Control V. Okay, Control V. You can paste that. So you can actually highlight part of the text and copy that and bring that down and Control V to paste that. You can try this function. Because when I do something, for example, it's a really long function, I want to copy that down. I will use this function to copy part of that down. Okay? So we'll use that to times this. So that will equals to 63.4349. So let's say that 63.435. 63.435 degrees. Okay, so where's the acute angle? Where's the acute angle? I don't really know. Because it all looks like 90 degrees, or one is 89 and the other is 91. Like I don't know which one is larger. But which one I can find? I can definitely find out this angle. Let's say that's theta 3. So what is theta 3 equals to? Theta 1 will equals to theta 2 plus theta 3, right? By the property of the triangles. The exterior angle will be the two interior angle add up together. So theta 3 will equals to theta 1 minus theta 2. Okay, so we will use, okay, remember to keep exact values. Do not round up or round down too early. Where's the value I have? So is this value add up by 180? I have this 161, and I will use that to subtract the 63 one, and that gives me 98.13. Okay, so I have 98.13 degrees. Let's round it to 2 decimal places. So 98.13. But that's not the acute angle. Okay, it's over 90 degrees. So you will say the acute angle is 180 degrees degree minus 98.13 degrees. That will give you, okay, use that to subtract 180. That is 81.87. 81.87 degrees. Okay, so the angle, acute angle formed by these two linears will be 81.87 degrees. All right. Any questions? Any questions? No? Okay, if there's no questions, let's move on. Okay, to the next exercise. I think I changed the order. Have I changed the order? Yeah, I changed the order. I skipped D and I go to E first. For E is matrices. How many of you feel like you don't know matrices at all still? No? Okay. Okay, so we don't need matrices too much. We only use matrix in transformation. Okay, we use matrix to do transformation. So I will just generally talk about what are they. Okay, what each term means. So first of all, matrix is a rectangular array of numbers arranged in rows and columns. And we have entry. So all the numbers inside the matrix will call the entries. Okay, they are the entries. Capital letters can be represent the matrix. And A, I, J is referred to the elements in the ith row and jth column. So the most important thing maybe is the dimension of the matrix, which is the order outside the size of the matrix, is the number of rows times the number of columns. So for example, you have this A equals to, you have 3 rows and 2 columns that equals to 3 times 2. But you won't evaluate that to say that's a 6, okay? You won't say the dimension is 6. You will say the dimension is 3 times 2. You are not going to evaluate that. So lowercase a 2, 1 is say row 2 and column 1, so which is a -1. The entry is -1. So two matrices A and B are equal when they have the same number of rows and same number of columns, and also they have same number or entry at the corresponding position. In other words, they must be looks identical, okay, exactly the same. For example, A and B, they all have 1, 2, 3, 4 as entries, but they are not at the same position, not at the corresponding position. So A and B are not equivalent. For additional and subtraction of matrix, so first of all, the order must be the same. Okay, matrix A and B can be added or subtracted, which means they have the same order. If two matrices have different orders, you cannot subtract or add them. Okay. I'm not going to do the examples. There are here 11 examples, so you do that by yourself. Multiplication of a matrix by a real number. So how we can do real number? So A times a matrix. Basically, you times every entry by the number A. Okay. So now let's do one example. Okay, I will just show one example. So find the matrix X such that 2A plus X equals to B. So what is 2A? 2A is 2, 3, 2 minus 1, 1 plus X equals to 0 minus 4 minus 8 and 8. So that gives you 6, 4, -2 and 2 plus X equals to 0 minus 4 minus 2 and 8. X equals to 0 minus 4 minus 2, 8. Subtract 6, 4 minus 2 and 2. And X will equals to, you subtract the corresponding position. 0 minus 6 will be -6. Minus 2 minus 2 give you 0. Minus 4 minus 4 will give you -8, and 8 subtract 2 will give you 6. So X will be 6, -8, 0, and 6. Okay, that's how we do subtractions and additions between matrices. Okay, number 9. Number 9, I think is the most difficult part. Okay, number 9 is the most difficult part, which is multiplication of matrix. So first of all, you need to test about, is that alright to times those two matrices together? So requirement is the number of columns of the first matrix needs to be the same as the number of rows at the second matrix. Okay, you must test that. So what that means, if I want to do A times B, if I want to do A times B, say we have M times N as the order. Okay, M times N is the order for A. And times another matrix B. The B must have, like say, for example, I have K and K times Q. Okay, the order is K times Q for B. If they can times together, must be N equals to K. Okay, if N is not equals to K, A and B cannot times together. Okay, if N is not equals to K, those two matrices cannot be times together. If N equals to K, the result matrix will be C. Let's say the result will be C. The matrix C will have order M times Q. Okay, so M and K, they just gone, and what has been left is M and Q. So the result matrix C will have M times Q. Okay, M times Q. So A times B and B times A will be different. A times B and B times A will be different. So because when you do B times A, it's K times Q times M times N, okay? But your Q and M is not equal, okay? Q and M is not equal. So B and A will be undefined. But A times B can have an answer, okay? If your M and Q is not equal, then B times A will be undefined, but A times B is alright. Let's do one example. Let's see A times B and A times B. Let's do example 2. I'll show you example 2 here. Let's do example 2. So A times B. So what is A times B? A times B will be this times this. This is a 2 times 2 matrix, and this is 2 times 1 matrix. So it is alright to times them together. And how we can times 2 matrix together? We will circle the row for the first matrix and circle the column for the second matrix. Okay, that is row 1, that is row 2, that is column 1. Okay, that is column 1. So let's use row 2 to times column 1. The answer will be at row 1 and column 1. Okay, so row 1 and column 1. So how we can times row 1 and column 1? So it's 3 times 1. The first number times the first number plus the second number times the second number. Okay, you use row 1 to times column 1. Okay, the next thing you use row 2 to times column 1. Okay, row 2 times column 1 will have result in row 2 column 2. Row 2 column 1. Row 2 times column 1, the result will be row 2 column 1. So row 2 column 1 is the box below that. You use the first number times first number plus the second number times the second number. So that gives you 1 and negative 2. Okay, that is A times B, right? That is A times B. Let's think about B times A. B is 1, negative 1. A is 3, 2, minus 1, and 1. This is 2 times 1. This is 2 times 2. those two numbers are not the same, so this is undefined. This is undefined. So you can see I can times A and B, but I cannot times B and A. Okay, A and B is okay, B and A is not alright. Let's show you another example. Let's see the front example. I want to find the value of A and B. So if I want to evaluate AB, like this. Okay, so this is row 2 times row 2, this is row 2 times row 2. So those two numbers are equal, so I can times them. The result must give me a 2 times 2 matrix. Okay, the result must give me a 2 times 2 matrix. So how we can do that? We'll use the first one's row and the second one's column. So this is called row 1, this is called row 2. This is column 1, this is column 2. Okay, so I'll use row 1 to times column 1, so I have row 1, column 1. So row 1, column 1, how we can times them? 1 times 5, the first number times first number, second number times second number. Then I will use row 1 to times column 2. Okay, row 1, column 2, I will result in row 1, column 2. So use the first number times the first number plus the second number times the second number. Okay, next one will be row 2 times column 1. I will have row 2, column 1. So row 2, column 1, 4 times 5 plus 2 times 6. First times first plus second times second. The last one is row 2 times column 2. That will result in row 2, column 2. So it will be 4 times 1 plus 2 times 3. So let's calculate that. 5 plus 18. 23. 20 plus 12. 32. 1 plus 9, which is 10. 4 plus 6, which is 10 as well. Okay, you need to try to calculate B times A. So B times A here, it can be calculated because it's 2 times 2 times 2 times 2 matrix. So it's okay, the middle two numbers always equal. But like the answer will be different. Okay, the answer will be different. So if you can use B times A, why that would be different? I will use row and row, column and column. So row 1, row 2, column 1, column 2. So when I have row 1, column 1, I'll use 5 times 1 plus 1 times 4. That will give me 9. Row 1, column 2 will be 5 times 3, 15. 15 plus 1 times 2, which is 17. Row 2, column 1 will be 6 plus 12, which will be 18. Row 2, column 2 will be 6 times 3 plus 3 times 2. So it's 18 plus 6, which is 24. And you can see A times B is not equals to B times A. Okay, A times B is not the same as B times A. Okay, enough example here. I'm not going to show more and I'll go to next page. Okay, next page. I need to finish the next two pages. Okay, square matrix. So what is a square matrix? Square matrices have same number of row and same number of column. 1 times 1, 2 times 2, 3 times 3, those kind of matrix. Identity matrix is a square matrix. So identity matrix first of all needs to be a square matrix, otherwise it cannot be an identity matrix. So identity matrix has the element 1 on the main diagonal but 0 anywhere else. So where is the main diagonal? You have 2 diagonals, but main diagonal will from left top to the right bottom. Okay, left top to the right bottom. That will be the main diagonal, not the other way around. Okay, not the other way around. Okay, what is inverse matrix? Inverse matrix, so let's say we have A and A inverse. They times together should be inverse times A, and that will give you identity matrix. Okay, so that's the definition for inverse. So the inverse in numbers will say 2, and the inverse is a half. So 2 times a half will give you 1. That's for numbers. But in matrix, then the original matrix times the inverse matrix, that will give you the identity matrix. So identity matrix is same as 1 in number. So that's the definition for inverse matrix. But how we can find inverse matrix? We only think about 2 times 2 matrix as inverse matrix. Okay? We only do matrix for 2 times 2 inverse matrix in year 12. So what is inverse matrix? It's just a formula you must always remember that I put in red colors. A inverse equals to 1 over AD minus BC, which is the main diagonal, subtract the other diagonal. And I will swap the number in the main diagonal and I'll put negative signs on the other diagonal. Okay, so just a couple of things you need to do. First of all, find the constant 1 over AD minus BC. And then I will swap the number on the main diagonal and I will put negative signs for the other 2 values. Okay, now we come to the really important thing. We talk about this much. I only want to talk about one thing actually, which is the determinant for the inverse matrix, also for a matrix. So what's the determinant? The determinant will be like, what's the discriminant for quadratic? It is b squared minus 4ac. If that's greater than 0, we will have 2 solutions. We'll have no solutions if it's smaller than 0. So it's something to decide whether there will be a solution or not. So determinant is AD minus BC. Why AD minus BC is important? Because if that number is 0, I cannot evaluate things. What is 1 over 0? It's undefined, which means the inverse does not exist. Okay, if I have AD minus BC equals to 0, which I'll have 1 over 0, which will apply that inverse does not exist. Okay, inverse does not exist. So if A not equals to 0, A inverse will exist, and A is said to be a regular matrix. If A inverse doesn't exist, it will be a singular matrix. Okay, so I have finished all the concept for matrix. Oh, good. Okay, I don't like to teach matrix because we just use it one place, which is later on what I'm going to talk about. Okay, example for matrix A, find the determinant. So the determinant A will be AD minus BC. So it's 3 times 6 minus 1 times 2, which will be 18 minus 2, which is give you 16. Which means I can find inverse for this. So inverse will be 1 over AD minus BC, which is 1 over 16. And I will swap the numbers on the main diagonal and I'll put negative signs for the other 2 numbers. And that will give me 6 over 16 is 3 over 8. Minus 2 on 16 is minus 1 on 8. Minus 1 on 16 and 3 on 16 for this one. Okay, that's the inverse matrix. That's the inverse matrix. Okay, for the next one, ax plus b equals to c, where b is that, c is that, and a is given in the front. So I want to solve for x. Okay, you know AX must be equals to C minus B. But we cannot divide by a matrix. We cannot say we want to divide by a matrix. So what we will do is we times an inverse matrix to make that become an identity matrix. Identity matrix times any matrix will be that matrix. So, but remember, I times this A inverse in the front, connect next to the A. I need to put this A inverse into the front on my right hand side as well, which means I cannot put A inverse here. Okay, I cannot put A inverse here. It must be the corresponding position. If I put in A inverse in the front, you must put A inverse into the front as well. Okay, so A inverse goes into the front. So what I have here, those two matrices give me identity matrix. So identity matrix times X will still be X. Okay, identity matrix times any matrix will still be that matrix. 1 times any number will still be that number. Okay, shh. So A inverse will be C minus B. A inverse times C minus B. So let's put all the information in. What is A inverse? A inverse is, okay, let's put A inverse as 1 over 16. 6 minus 2 minus 1 and 3. What is C minus B? So C minus B will be 3 minus 4 will give you negative 1. 4 minus negative 1 give you 5. 2 minus 2 give you 0. 6 minus 2 give you 4. Okay, that's C minus B. And X equals to 1 on 16. I just put the 16 outside. I don't want to carry the 1 on 16 to calculate all the time. And you have two matrices times together. It's the row times the column. Okay, the row times the column. So that gives you row 1, column 1, row 2, column 2. So row 1, column 1 times together will give you negative 6. Row 1, column, row 2, column 1 will give you 1. Okay, row 1, column 2 will give you 30 minus 8, which is 22. And row 2, column 2 times together will be 12 minus 5, which is 7. Okay, which gives you those numbers. So X will be minus 3 over 8, 11 over 8, 1 on 16, and 7 on 16. Okay, that's how we solve this. And this is the important thing. Okay, this is the important thing. I will use this. I will use this for matrix, for transformation questions. But I really want to complete. I really want to complete the next one because it's connected with negative 1 perfectly. Okay, so what matrix can be used except transformation? That can be used to solve simultaneous linear equations. So how we can set up? We can only solve simultaneous equations for two variables, okay, x and y. So how we can set up this? We have two equations. I will put two equations both in y, ax plus by equals to c form. I want to set up that into this form. So I will have minus 4x. Let's say we have minus 4x plus y equals to 3 minus 5x plus 2y equals to negative 6. And then how we can set up the equation? What we will say is minus 4 minus 5, 1 and 2, which is the coefficient of x, y in front. And I'll put the variable here, x and y. And that will give you the constants 3 and 6. Okay, that will give you 3 and 6. How we can solve for that? Let's say that is a matrix A, that is a matrix X. What we're looking for, that is a matrix B. So we have AX equals to B. X will equals to, so what I will do is A inverse times AX equals to A inverse times B. So that become identity matrix, which give you A inverse B. And then I will have X equals to A inverse times B. So what I should do here is XY should equals to this matrix inverse times 3 minus 6. Okay, so what that equivalent to? So XY will equals to, okay, AD minus BC. So 1 over AD is minus 4 times 2 minus BC, which is 1 times negative 5. Times, I will swap the number on the main diagonal and I'll put negative sign onto the other two. 3, negative 6. So XY will give me, that's 1 over negative 8 plus 5, which is negative a third. Okay, what I should have here, I will have row and 1 column. So that's row 1, that's row 2, and that's column 1. Row 1 times column 1, 2 times 3, which is 6, 6 plus 6, which is 12. Another one is 15 plus 24, 39. Okay, we have 39 here. And then times the negative a third in, that's negative 4, negative 13. Okay, now I have solved out that so my x equals to negative 4 and my y will equals to negative 13. Okay, I have finished up to matrix. I'll go through a really important concept tomorrow, which is maybe Wednesday. Wednesday I have like really important concept for 2F. This must be on VC exam, so I'll talk about that tomorrow. But like remember what we have learned today, because I will use what we learned today to go through next lesson thing. Okay, so we'll stop here today.